yes. Hello, 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 hello. Welcome back to Server Dreamer Online Classroom. Okay, for today, our lesson is now about Venn diagram. Okay, we are now on the week 2 of quarter 1, which all about Venn diagram. Okay, so let's start. Let us define first what is Venn diagram. Venn diagram, it is a chart that demonstrates how different ideas are related, or it is an illustration that uses circles to represent sets. By the way, Venn diagram named after by the British mathematician John Venn. Take note, John Venn, a British mathematician from 1834 to 1923, John Venn. Okay, so let us illustrate what is Venn diagram for you be able to familiarize Venn diagram. Okay, so let's have, for example, this square rectangle, for example. Yan. As the definition, Venn diagram is an illustration that uses circle to represent set. Okay, for example, this is the universal set. Again, what is the definition of universal set? Okay, later on, we will define it one by one. So we have this one circle to represent set A. Another circle to represent set B. So, from the definition of Venn diagram, it is an illustration that uses circle to represent sets. Okay, did you get it? Okay, so let's proceed to the next. Okay, for example, this is universal. Okay, for example, we have the following elements of universal. We have 1, 4, 5, and 6. And we have the element from set A, 1 and 4. And set B, we have here the element 5 and 6. So how are we going to write the following elements to the diagram? For example, we have set A. We have the elements. So we have to put the elements inside the set A circle. The first circle, which comprises elements from set A. We have 1 and 4. So that is set A. For the set B, we have the following element, 5 and 6. So we have the elements 1, 4, 5, 6. From the definition, we are going to recall the universal set are the elements in the discussion. These are the elements in the discussion. What are the elements? 1, 4, 5, and 6. But we have set A and set B. Did you get it? So that is universal set. Okay, so let's proceed. Union of sets. What is unions of sets? Again, we have already discussed it last week. When we say union of set, if you're going to get the synonyms of the word unions, we have merging, combination, meaning to say we are going to merge, to combine all the elements. Did you get it? Okay, so let's have that. Use the Venn diagram. We have the universal set. We have the following elements 1, 2, 3, 4, and 5. We have the elements from set A and set B. And take note, we have common element. We have already discussed common element. What is common? 4. So in the Venn diagram, let's put 4 on the both circle. So meaning to say, common element from A and B. So let's have from A, we have 1 and 3. And we have from B, we have the elements. We have already 4 here. So we have 2 and 5. As we define again, union of sets denoted by the curve arrow up. The symbol curve arrow up. So we have here to read A union of B. A union na B. So what are the elements? As we can see again, we are going to combine all the elements. So we have elements 1. Let's just write first A, 3. Then the common element 4 plus from the set B 2 and 5. So we have the following elements 1, 3, 4, 2, and 5. You can write also the elements in order of the number. Okay? So that is union of set. You are going to combine or merge or the element. Okay? Okay, let's proceed to the next. Intersection of sets. This is the second one, intersection of sets. So let's have first elaborate intersection. For example, there's a way going to your friend, another way to another your friend. So you're going to go to your friend at the same time. Where will you going to meet with your friend? Okay, for example, it is you. You're going to the house of your friend. Then another friend here. Then you go you're going to house of your another friend. So here. So where are you going to meet by your friend? Okay, here. So this is what we call intersection. So meaning to say that is common element. So we have the symbol for common element. For intersection, we have curve, arrow down. So we are to write this, we have A intersection B. So if you're going to illustrate using the Venn diagram, we have here the circle 1, set A, then another circle, set B. Where is the intersection given the two circle? This is what we call intersection from the two circle. So that is Venn diagram. That is intersection. For example, we have the universal. We have the following elements: A, B, C, D, E, and F. And we have set A, B, C, and D. And we have set B. We have the following elements: B, D, E, and F. So we have A intersection B. What are the common elements between the two given sets? We have B. So common element B. Another C, no C. So we have D and D. So we have D. No more? Okay, so these are the common elements. So therefore, what is the intersection for example, or A intersection B? What are the elements? B and D. So that is intersection of sets. Okay, we have the third one. Complement of a set. Again, complement of a set denoted by the symbol prime. So we have A apostrophe. This is read as A prime. Okay, if you're going to illustrate using the Venn diagram, for example, we have here universal and we have set A. So we have set A. So this is how are we going to write complement of A. So what are the elements? These are the elements that does not contain in set A. All the elements that cannot be seen in set A but can be seen in the universal set. So these are the complement of A. Those outside the set A, outside the circle. If we are going to illustrate this, for example, we have set A, 2, 4. And we have the universal set. 2 and 4 is already included from set A. So we have the remaining 6, 8, and 10. So what are the element or complement of A, which is A prime? These are the A prime or complement of A. We have the following element. Outside the set A, outside the circle, we have 6, we have 8, and we have 10. So these are the complement of A. So if we are going to answer this one, we are just going to cross the common element And what are the elements that is not contained in set A, which can be seen in the universal set? So we have 6, 8, and 10. So there, that is the complement of A. All the element that is not contained in set A. Okay? Did you get it? Very good. Okay, so we have the last one. We have what we called subsets. Again, subset. Subset, we have the symbol, the curve, arrow right. Okay, so we have to, this one. X is a subset of Y. Meaning to say, it means every element from X or set X is an element of Y, of set Y. Did you get? All the elements of Y is an element of X. Okay? Contained from X. Okay, for example, let's have universal set. First 5 counting numbers. What are the first 5 counting numbers? We have 1, 2, 3, 4, and 5. And we have X, set X. Every numbers, even numbers from 1 to 5. What are the even numbers? Numbers that can be divided by 2, there is no remainder. Okay, so we have 2, 4. And we have Y, we have the element 2. So let's illustrate using the U. So that are the set of elements, first 5 counting numbers. We have 1, 2, 3, 4, 5. So these are U, the elements of the universal set. And we have to get the elements of the set X. What are the elements? First 5. So let us circle, just circle. These are the elements of set X. Even numbers. Is it correct? Even numbers? Oh, wrong. So therefore, what is our answer? What should be, what elements only encircled to get for the circle of for the set X? What are the circled element? Even numbers only, which are 2 and 4. So these are the elements from set X. Did you get? 2 and 4. That is the set X. And we have set Y. We have elements 2. So these are Y. So that is Y. Element of Y is an element from set X. Did you get it? That is subset. Meaning, all the element from Y are element from X. That is subset. Very good. Oh yeah, okay, did you get it? Very good. That's all for today. That's all about Venn diagram. Okay, so wait for the next video. That is problem solving involving or using the Venn diagram. We are going to solve sets using Venn diagram.